Hello everyone, welcome back to the channel. In this video we'll discuss the tornado outbreak that occurred on May 8th, just a few months ago. This was a widespread severe weather event that began in the Ozarks and in the Mid-South region, then ended up producing significant severe weather across the Tennessee Valley and Southeast later that night. Over 500 reports of severe weather occurred from this event, with the majority of the tornado reports coming from Tennessee and Alabama. In this video I will talk about the meteorology behind this setup and why the Tennessee Valley was the favored location for tornadoes. If you enjoyed this video, leave a like and subscribe, and we're going to get started. So this is a pretty well forecasted event, and the SPC began issuing outlooks for the day 6 period. By day 3, they had a large enhanced risk, level 3 out of 5, outlined from the Ohio Valley down into the Southern Plains, mainly north of where the main event occurred. Most of the severe weather reports and tornado reports came from southern Tennessee and Alabama. And so the initial expectations were that storms would develop in the enhanced risk region and then move south overnight with mainly a damaging wind threat. And that remained the expectation into the day 1 period. And they did upgrade to a moderate risk, level 4 out of 5, for southern Missouri down into Nashville. This included a 10% hatched tornado threat, meaning at least a 10% chance of significant tornadoes within 25 miles of a given point, as well as a significant damaging wind threat and a significant hail threat. It wasn't until the very last outlook of the day at 8 p.m. that the moderate risk was shifted south into the central Tennessee Valley and included Huntsville, Alabama. This included upgraded tornado probabilities to a 15% zone, given that multiple tornadic supercells were ongoing across the risk area. And so that may seem like a small probability, but remember that these probabilities are for a tornado within 25 miles of any given point. So that's 15% chance of a tornado within 25 miles of where you are at. So that's a pretty significant probability. In a discussion they issued right before the convective outlook was released, they discussed the development of these supercells in North Alabama and Southern Tennessee, stating that these occurred as a response to the increase in the warm air advection associated with the low-level jet. And so I talked about the low-level jet in previous videos, and this plays two critical roles in severe weather. The increase in low-level wind shear to produce tornadoes, and increase in warm air advection from the Gulf of Mexico. So if you're unsure of what any of this means, check out my video talking about the 4 main ingredients of severe weather. That will help explain this a little bit more in depth. So another thing I'll point out is comparing the radar imagery between the Ohio and Tennessee valleys here in this discussion that they posted. In the southern mode here, we have storms that are much more discrete in nature. You can kind of see here the randomness here in the cells, and they are fully isolated out by themselves. And compared to areas further north, storms are a lot more clustered up in northern Tennessee and southern Kentucky. So the storms to the south, they aren't competing as much for the favorable environment that they're in. And so this is a big reason why the tornado threat was more prevalent in the southern storms than compared to the north. And we'll talk about kind of why that was a little bit later on. So that covers the forecast leading up to this event. Now let's dive into the meteorology behind this setup. So I'm going to start with the upper air charts, and we're going to look at 300 millibars and looking for the jet stream. The main branch of the upper level jet is stretched out across much of the continental United States. So this is kind of where the main branch of the jet stream is. And there also looks to be a second branch of the jet stream that is across the southern United States here. And so this creates broad upper level divergence across the Ohio and Tennessee valleys, which creates the synoptic forcing for severe weather. And then by 7 p.m. on the 8th, you can see a smaller jet streak develop within that southern branch of the jet. And so we break this down into quadrants. This puts North Alabama and Tennessee in what we call the left exit region of this jet streak. And so this is a favored region for severe weather, which is where most of our severe weather and tornado reports came from, as you can see. So at 500 millibars, I'm going to go down here. So at 500 millibars, we are looking for the trough and ridge pattern. So we have a very large upper level low that is positioned over the northern United States, and this carves out a large long wave trough across much of the continental U.S. This, along with the 300 millibar jet, were the main synoptic features in play for this event. So now let's look at the lower levels of the atmosphere. So here we're going to see the low level jet here at 850 millibars. And so again, this is responsible for bringing up that warm, moist air from the Gulf, as the SPC noted, and that's what triggered those individual supercells to develop. So we had about, those wind barbs here show about 35 to 40 knots of flow out of the south-southwest across Dixie Alley. So that's enough here to increase the low level wind shear, and that's needed for these supercells. So surface winds out of the south here, and at 850 millibars, we have winds out of the south-southwest, and then in the upper levels of the atmosphere, we have winds out of the west-southwest. So this creates a lot of turning in the winds with height, and creates that strong directional wind shear for those supercells to produce tornadoes. Down at the surface, we have a broad surface low that is over the Kansas, Oklahoma, and Missouri corridor, with a cold front trailing down south into Texas, and a warm front that's a little hard to tell, but kind of apparent across Missouri and Middle Tennessee. And then by 7 p.m., this is the warm front really just kind of stays in place across Middle Tennessee. And this ended up cutting off areas north of I-40 from the deeper warm sector, which is another reason why the severe weather threat shifted to the south. So that's going to cover the meteorology behind the setup. Now let's look at some of the observed data from this event, starting with visible satellite imagery. The higher level cirrus over Kentucky is from ongoing storms that ended up having a significant impact on the environment along the warm front. So as we go through the day, you can see those higher level cirrus shift to the southeast from those storms that were ongoing. And then while these did quickly move to the southeast, recovery is short-lived as additional storms redevelop. You can tell on satellite where the warm front is located, and so that tended to reinforce the warm front to the south. South of this ongoing convection, however, you see those bubbly cumulus clouds across southern Tennessee, Mississippi, and Alabama. And so that's a sign of significant destabilization, which aided in the severe weather threat. You can see by early evening those overshooting tops from those storms that were ongoing across the Tennessee Valley. So a sign that we had pretty significant convection ongoing. We can see the impacts of the storms by these storms by looking at some of the surface data from this event. So I'm going to back up here to probably around midday Central Time. And so in eastern Tennessee and Kentucky, temperatures were down into the 60s, while areas south and west of that, we have temperatures in the low 80s. So storms from early in the morning left a rain-cooled boundary kind of right along this corridor. And this rain-cooled boundary kind of stayed in place through much of the day. Much of the Tennessee Valley was unaffected by it. In fact, temperatures remained in the 80s across North Alabama well into the evening hours. And with dew points in the mid-70s, this created a pretty unstable atmosphere with favorable thermodynamics in play. So we're going to see in the soundings from this event. So let's look at the soundings here. So this is an observed sounding from Birmingham, Alabama on 7 a.m. at 7 a.m. from this event. While this is south of most of where the event took place, this gives a pretty good idea of the overall environment. First thing to note here is this is a pretty classic loaded gun sounding, with a deep moist layer extending up to about 850 millibars, where you see the red temperature and green dew point lines pretty close to each other. And then above that moist layer, we have a pretty nice warm nose at 850 millibars here, which caps the atmosphere and prevents storms from developing until stronger forcing arrives. This allows stronger instability to develop later in the day. And this is a pretty classic sign of a significant severe weather event that is about to occur. These types of soundings are pretty strongly correlated with some of the more significant severe weather events that have occurred in the past. So I won't focus much on the hodograph in this chart, since this is south of the main risk area, and I'll show a model sounding from Huntsville that I believe gives a better representation of the wind profile. So at 7 p.m., sounding from Birmingham shows a pretty impressive thermodynamic profile. The cap has completely eroded, and we have pretty steep lapse rates throughout much of the column here. This red temperature line is the temperature change with height. And so this leaves us with a pretty strongly unstable atmosphere, and with lots of CAPE here. This is the temperature difference between the red dashed line and the temperature line here. And this down here shows how much CAPE we have, and we have about 3,000 joules per kilogram of mixed layer CAPE, which is pretty high for early May. The wind profile also looks pretty favorable for severe weather, with a pretty strongly veering wind profile as you go up with height, and this creates a nicely curved clockwise hodograph, which makes the environment favorable for an all hazards threat. So now let's look at the sounding closer to the event. This is a sounding I pulled from the HRRR model in Huntsville, Alabama at 9 p.m. So as storms were ongoing during the evening. And this shows a pretty similar thermodynamic profile from Birmingham, with about 2,900 joules per kilogram of mixed layer CAPE. So pretty high for this time of year. And also shows pretty strong low-level instability. This is the 0 to 3 kilometer CAPE. So this is CAPE in between the 0 to 3 kilometer layer. And it shows about 120 joules of CAPE in this layer. And you really only need more than 50 for a tornado threat. So this is very favorable for tornadoes. And the wind profile is also pretty supportive of a tornado threat, and a strong tornado threat at that as well. With, again, nicely curved, or nicely veering winds with height, creating pretty large clockwise curved hodographs. And so this, coupled with the strong thermodynamics in play in this environment, this created a pretty favorable atmosphere for a significant tornado threat, given a discrete storm mode, which is what we certainly had that evening. So hopefully that helps explain why this event sort of snuck up at the last minute and produced one of the more significant outbreaks we've had here in the past several years. So this is the storm survey from the National Weather Service in Huntsville, and it shows a total of 20 tornadoes confirmed from this event. This came from 2 different rounds of storms, the first of which were discrete supercells that produced multiple strong tornadoes, a couple of one EF2 and a couple of EF3s. Then later in the night, storms tracked south, producing multiple weak tornadoes across northeast Alabama and southern Tennessee. I'll include a link in the description box below to this survey and of radar imagery from this event, as well as some other past videos that will help further explain some of the topics discussed. So with that, thank you for watching, and I'll see you in the next video.